once we know how to calculate flux, it's time to actually look in more depth at Gauss Law. And the first thing I'm going to talk about here is this idea of a Gaussian surface. And a Gaussian surface is a closed surface that typically encloses, which means that it surrounds, some charge. Really, though, you can think of it as being any type of closed surface. And sometimes the enclosed charge will actually turn out to be zero, as we'll see fairly soon. So in this case, we have phi, so the flux through this closed surface, I have a subscript c, is equal to the integral, and we put a circle through the integral. That is meant to show that we're integrating around a closed surface. And then we still have E dot dA, so we still have the same dot product. Gauss law then applies specifically to a Gaussian surface, and it says that the net electric flux through any closed Gaussian surface is equal to the net charge inside the surface divided by the permittivity constant. So mathematically, we can write phi c, the flux through a closed Gaussian surface, is equal to the net charge, which I'll call Q in, so that's Q inside the surface. That's the charge that's enclosed by the surface, that's within the surface, divided by the permittivity constant, which is epsilon naught. Now this is the same electric flux through a Gaussian surface, so I can say that this is also equal to this closed surface integral of the dot product of the electric field dot dA. Gauss law and this pair of equations relating the Gaussian surface and the electric field passing through that surface and the area and the charge enclosed by that surface lets us actually learn a lot of interesting things about conductors in electrostatic equilibrium and about electric fields near groups of point charges, so we don't necessarily have to use the kq over r squared to find the electric field anymore. When you're applying Gauss law to charged insulators, the key idea is to choose a Gaussian surface, remember that's a closed surface, with the same symmetry as the charge distribution. And the reason this is a key idea is because it makes the math a lot easier. And you can see the following videos for specific examples of this.